Hi, and welcome to Physics 2212 Lab 2. The purpose of this lab was to determine the electrostatic interactions between charged pieces of tape with other objects. It was also to investigate the accuracy of different computational models compared to the physical system. Starting off with some key principles, Newton's second law states that the force is given by mass times acceleration. This can be extended to the gravitational force, where force is given by mass times the acceleration due to gravity, which is 9.8 meters per second. Then we have Coulomb's law, which states that the charge between two charged particles is given by the following formula, where each Q1 and Q2 represent the charges of two particles, and R is the vector pointing from the source charge to the charged particle being acted upon. K is Coulomb's constant, given by 9 times 10 to the 9 Newton meters squared per Coulomb squared. We also have the principle of superposition, where the individual contributions of electric fields from different charges sum to give the net electric field. Several key assumptions for the computational model was that all the charge was distributed in a single line. We also assumed that each tape had the same amount of charge evenly distributed along the length of the tape. We also assumed air resistance could be ignored. For a brief preview of the results, it was determined by the computational line charge model that the charge on each piece of tape was 3.604 times 10 to the minus 9 coulombs. This is quite similar to the amount of charge calculated for the physical experiment in Lab 1, which was 3.63 times 10 to the minus 9 coulombs. The dimensions of the tape are shown here, with the suspended tape having a mass of 0.1 grams. One charged tape was placed at the separation distance required to levitate the suspended tape, which is 1.1 centimeters. The system is the suspended tape, as we are measuring the effects of the electrostatic force and the weight force on the tape. The surroundings consist of the held tape underneath and everything else. For the computational model, we first established the necessary initial conditions such as mass and the acceleration due to gravity. Next, we defined the electric field function, which calculates the field at an observation location due to a particular charged particle. Next, we defined a function that creates a line of evenly distributed charge, which will represent our tapes. In the second part of the code, we then create the top and bottom tape using the line charge function. In these loops, we then calculate the electric field at each charge in the top tape due to every charge in the bottom tape. We then calculate the force acting on each charge in the top tape by multiplying their charge by the electric field acting on them. For the computational model, we find that a charge of 3.604 times 10 to the minus 9 coulombs is the charge along the top tape, such that the gravitational and electric force equally balance each other out. Here, the white and yellow arrow represent the electric and gravitational force respectively. Here, the green arrows show the net electric field acting on each point charge on the top tape. Both the computational model and physical system gave extremely similar results. Possible sources of error include not having enough point charges along the top tape. Another source of discrepancy may also be because the tape is better approximated as a flat rectangular area of charge, not just simply a line of charge. Also, the measurements during Lab 1 may not have been accurate enough. When the tapes are modeled as a single point charge, their charge was calculated at 3.63 times 10 to the minus 9 coulombs. The value for the line charge model was given at 3.604 times 10 to the minus 9 coulombs. These estimates differ because a line charge model is more accurate than a point charge model. This is because a point charge model is only valid for a far field approximation, where the distance between the two tapes is much greater than the actual size of the two tapes. Additionally, tapes are real extended objects, not just points in space.